Hey everybody, how you doing? My name's Jason Richards, aka the Data Detective, and I decided, because I need to keep myself busy, to start creating series of videos to kind of highlight technology, the data science process or analysis process, and to kind of combine my two passions of data and sports together. So uh, I wanted to start creating these video series. So maybe you can learn a little something about some of the cloud technologies and how to store data and use some of these technologies to process data and analyze data. From a programmatic standpoint, I'm going to be using probably Synapse Spark notebooks in there. But the first thing I needed to do was find some sports related analysis problems that may not be out there in the world right now, but trying to create them, and that's part of this whole process is trying to solve a problem, right? That's what the focus of science is trying to do is find a problem, create a hypothesis, and then start building an experiment to prove or disprove your hypothesis. So that's what we're going to go through in this first video is creating a hypothesis or finding a problem, creating a hypothesis, and starting this whole experimentation setup. And then we'll get into the technology part of things. But I think that I want to keep these short, and then on a weekly basis, I'll just add 10, 15-minute videos to show you different parts of the process for this. So I've already came up with a problem, and that's where we're going to take a look at this from the first perspective. Now I am using OBS, so I'll try to make my window transitions as seamless as possible in this. But this is going to be real time, so my problems are going to be in real time, although I may edit them out if I get errors. But that's really part of the whole learning process of programming and everything else. I have been out of Python practice for a while. I've been training and teaching AWS technical cloud services and Azure cloud services for the last 2 years. And before that, I was had a certification in data science and went to school for it. Did some experiments and set up some stuff. And if you see on my little sliding profiles up there, I have some articles on Medium I posted, and I really like data engineering or featureization and cleaning and dealing with data. That's one of my favorite processes on this. But in my GitHub and some other things, some of the projects that we were required to do were some were assigned and some we had to develop. And one of them was MLB pitch prediction, which I'll probably revisit in this series. But it took a lot. It takes coding and a good understanding of the logic behind what you want to do, and a lot of that's from a development perspective, a lot of that's like learning the path. So um, I know there's some videos out there where people just go right through the stuff, and it's like in the real world, there may be some really smart people. I am not one of those people by any stretch of the imagination. I'm not a super smart person, but I feel like I'm creative enough to look at problems and slowly go through the logic. I'm not the fastest in the world, but I do know how to read an error, and I think that's 90% of it too. Well, not 90%, but that's probably half of it, is being able to read an error, see what's going on, why it isn't working, and then try to solve the problem for that. That may involve some Stack Overflow, it may involve some other stuff, but I think that's part of the learning process too. So I hope you would appreciate the fact that I'm going to make mistakes in this whole process of doing these things. And, whether or not the hypothesis gets proved or disproved, we all learn a little bit about data science and data engineering and how to use cloud resources to start creating, workflows for development purposes and maybe even production purposes. So and if these are valid and if you like the videos or support the channel or anything like that, I could start connecting to real-time data through API through some of the sports APIs that are out there and test some of these and see if they're working in the real world. So while API, while streaming data is coming in, are these statistics or predictions or whatever, are they valid in for raw unseen data that's coming in, and there's a whole process setting that up. So that's super exciting stuff. So I hope you like this series. But the first thing that I want to dive into is the problem. So back in 2022, and I'll switch over to my Chrome cam here real quick. So back in, well, not in 2020, it is 2022, but back in 2021, late 2021, there was and I believe the NFL is going to start doing this now. So my first subject of focus is the NFL. So Big Data Bowl 2022. This is a Kaggle data set, and they did this back in 2021 too. It was a different data set and a different problem, but you could see here is this was specifically about special teams plays. So I hope you can read that, but it's talking about special teams plays in this. So they're talking about punts, kickoffs, field goals, extra points. Well, as far as I know, and I don't know, I mean, I watch enough ESPN and sports in general to listen to what's going on when the commentators mention things and statistics that they talk about when they're doing their whole spiels during the game. And one thing I've never heard is like a special teams ranking or factor or score. You know how they have QBR, and they may have offensive scoring power numbers and defensive scoring power numbers, and they have average punts and they have average this, but they don't have like a I don't want to say a power ranking, but just a ranking statistic in general for special teams. Special teams are the third element of a successful football team. You have your offense, obviously, your defense, and your special teams. And special teams, because they don't score a lot of points, or they're not, scoring a lot of points, typically that's the case. But I will say that based on what I've seen, throughout my football watching career, that special teams is an important part, and their game decision in a lot of cases, it could be game deciding plays that special teams provides, like the 3-point field goal that, you know, wins the game in overtime or takes over the score in the last second, or the extra point that does that same thing, or maybe the block punt that prevented them from, or that let their offense eventually score. So what the problem is that I want to try to see if there is a potential relevant uh, ranking or factorization, or factorization is the wrong term here, but some type of ranking item that we can place on special teams that can be utilized and kind of seen, uh, based on a team's special teams performance. So that's the problem. So the hypothesis is always, when you're dealing with problems and you develop hypotheses are either true or false. So, or, you know, valid or not valid, or however you want to point that. So the hypothesis in this case is it possible, or we will be able to create a ranking for our special teams. So this Kaggle data does have data associated with it. Now I'm not logged in right now, so I can't show you like I suppose I could sign in real quick and sign in with Google. Sign in with Google and check my phone. So I'll sign in real quick. Multi-factor authentication. I guess it's a. Ooh, what is going on here? Yes, it's me. All right. Give it to me. And just so you know, this multi-factor authentication is part of cloud processes. So that's something that if you want to know some more information about, well, we can get into that too. Definitely post questions and comments and things like that in the video as well, so I can get back to those. I work throughout the week, still do trainings and stuff, but I'll try on Fridays to answer questions and things like that. So you can see here that there's I've downloaded this data set, and you do have to be sign into Kaggle. And Kaggle is a Google-owned platform for citizen data scientists. I say that in air quotes, citizen data scientists to uh, submit notebooks that solve problems, and there's money associated with some of these contests, and they have they have non competitive data sets that you can go in and play with, but they're publicly available, and the NFL provides this data, and to stream this data in costs money in a lot of cases. Used to be free, but not so much anymore. So a great place to get these. Now what's great about this is that this is specific to special teams data. So now I can, associate and bring in without having to filter out plays from a existing data set. And you can see here I got 3 years worth of data, which is great, from 18, 19, and 20. That's a good relevant sample of data. So we want a sample, and a sample is a representation of a population. Now, if I went back to the night, all the way back to the 30s or 20s when the NFL started, then that's way too much, and a lot of that data is irrelevant now because of changes in rules and things of that nature. But we want a sample of the population, and the population represents the entire data set, which would go back that far. But we just want a sample of it, and the sample has to be relevant to things that are happening now. So when rule changes happen or when other things happen, then sometimes the data starts getting skewed in certain ways. Like you look at offensive performance that's changed in the NFL over the years, or quarterback performance specifically, that's because of rule changes like the Brady rule and some of those other ones that that have allowed more receptions to happen and more passing yards to be able to be completed, and it's extended, and for player safety and health it's great. But it does, affect the underlying data and the way that it's represented when you have predictions in place or analytics in place that are already set on certain data that have been over certain periods of time. So you'll always want the most relevant or recent data because it represents the most recent rule changes or things like that. Even in baseball now, the DH is everywhere. So when you look at pitching information for National League now, it may be a completely different situation from a batting and pitching perspective than the data is going to represent from any time before this year. So these are things to consider when you're dealing with data. So this is a good representative sample of the population of the data set. You can see here they're showing distribution, which it shows pictures of the distribution, which means any unique values or the what samples are in here. Here they're binning data in between like 1458 and 1743, so that's the counts within that, and they're binning this type of stuff and just giving you like representative distributions of the data and just like snapshots of it. So main ones, and we can iterate through the data later, but obviously in order to set up this experiment we need data, and this is where I grab the data from. All right, so got our problem, got our hypothesis, got our data. So what are we going to do with this? Basically, we kind of want to set up a situation where I'm going to bring up a whiteboard and kind of lay this out so that hopefully we get a little bit more understanding on this. So how I'm going to set this up. And I have a fancy little Surface Pen here, so I'll be able to use this. So our problem is a special teams stat, right? That's what we want. Our hypothesis is, you know, uh, we can create a relevant statistical representation of special teams performance. That sounds fancy. All right. So that's either going to be shown to be true or false. So we either prove this or we disprove this, that we can't make one. And NFL, if you're watching, I am available for interviews. So keep that in mind. We have, so our experiment is going to relatively be data or analysis on data. That's going to be our experiment. So our experiment's going to require equipment, right? So first of all, we're going to need the data, and we have data. I have data from Kaggle, and I think I have Kaggle data representing other plays, like from their 2021 one. It doesn't have, I don't think, 2020 data in it. It may, but we'll see if that one does. And we can perform joint operations, and I'll show you all that from a data engineering perspective. So data, we got Kaggle. And now we also need like an environment, our environment. And I just want you to know this hypothesis here, we're not getting into like serious, the scientific method. I'm just showing you the scientific method of creating these types of experiments. So first you have to have a problem. Second, you got to create a hypothesis, and then third, you're going to create your experiment. Now, typically an experiment is going to be a controlled environment. We're dealing with data, and the data's already been produced. I'm not changing the data, the raw data in and of itself to perform to me. Now, there may be personal bias in what I set up for this, but I'm going to try to remove that from this. So, meaning that I can't ignore any data just because I don't think it's relevant. We got to go through it all and make sure that we're being unbiased with all the data that's represented to us in the data. So that's one thing you do have to keep in mind about setting up experiments, is they have to be unbiased. Usually that's why they set up a control, meaning that there's somebody that gets a placebo or they don't get the treatment, and then there's others that do get the treatment. That way there's no bias in the operation. And also when you're dealing from a data perspective, we don't want to be biased with data. So some of this data contains information like how high a kick was, or what pattern it went when a ball was kicked off. Well, in my mind personally, I'm like, well, that may not be so much, that may not correlate very well with a special team's performance overall, but I can't take that as valid, not my opinion. That's bias. So I want to remove that as much as possible. So personal bias I'm going to remove by just making sure that we iterate through the entire data set and making sure that the data that we're using is representative of what we're trying to prove here, or what we're trying to do here is to create a relevant statistical representation of special teams performance. So the environment I'm going to use, and basically we're talking about data manipulation and applying some analytical techniques using some, data sciencey type packages in a notebook format. We're going to be utilizing notebooks. I already have an environment set up through Azure, and it's called Azure Synapse Analytics. And specifically their Spark environment, or their Spark notebooks. It's called Synapse Spark. And I already have it set up, which is why I want to use it. And the other reason is because on my local workstation, I don't want to be downloading like Python environments and Conda and all this stuff. It's just it just takes up space, and I like this tablet and I want to preserve it as long as possible. So I don't want to be downloading all these environments and libraries and things like that on my local workstation just to open up a Jupyter notebook and start working with things. So I'm going to work in Synapse Spark because it's something I can deploy out to Azure, and it doesn't cost me anything until I actually attach a cluster and run it. Again, if you want more information about that, I can provide that for you. So from an analytics perspective, or the processing of the data, we're going to do that. From storage perspective, we're going to use another Azure product, which is an Azure Data Lake, which I already have associated with the Synapse Analytics workspace. So it can load data directly into the notebook from the data lake, and I'll show you how to do that in the next video. But this first video, basically, we just wanted to cover this because we're already at, probably over a little bit of 10 minutes. We're at 20 minutes right now for the video, so I don't want to take a whole lot of time just doing that. So this week we're just making sure that we have a problem, we have a hypothesis set up, we have an experiment. I'm going to save this, or it should save this in the whiteboard all by itself, so I can do a review in the next video. So, which will probably be posted every Friday. I'm going to try to create these on Friday and post these on Friday. And again, I'm not editing these things out, or I'm going to try not to, unless I run into a serious problem that requires me to work through something. So imagine this is going to be a long series. But hopefully we can get through this particular experiment in a reasonable amount of time, and try to find out if we can create a statistical representation of special teams performance that may one day be called out on ESPN or during a Fox broadcast or whatever. So thank you for being here. Again, my name's Jason Richards. I got some links. Make sure you like the video. If you want to join and help contribute to the cause later on when we try to hook up to an API to test out some of these different theories, by all means do that. Post your questions, post your comments, be active and involved in this. And together, not only can you learn how to do these processes, we'll all learn together how to do these processes. But I like sports, so this is going to be pretty sports specific. Thank you for being here. It's been great. Have a great, good luck in whatever you're doing. I'll see you on the next one.